Welcome to this week's Contrarian Coding News. The current dominant and popular trends for accessing Google Gemini via its API heavily lean towards established, general-purpose programming languages like Python, JavaScript, Java, Go, and C#. These approaches prioritize developer convenience, leveraging official client libraries, comprehensive SDKs, and a rich ecosystem of frameworks. The focus is on rapid development, scalability, and broad community support, often abstracting away the underlying HTTPS communication. However, a truly disruptive, unorthodox, and rebellious contrarian viewpoint challenges this mainstream reliance on high-level abstractions and general-purpose languages, proposing alternative paradigms that prioritize radical transparency, domain specificity, or data-driven implicit interactions. Here are three such viewpoints. The anti-framework, anti-library stance, embracing raw HTTP/S and text-oriented languages for ultimate control. Contrarian viewpoint. The prevalent use of official SDKs and client libraries, while convenient, introduces unnecessary layers of abstraction, bloat, hidden complexities, and potential vendor lock-in. A truly contrarian approach advocates for bypassing these abstractions entirely, accessing the Gemini API directly via raw HTTPS requests using minimalist tools or programming paradigms that prioritize transparency and low-level control. This means favoring shell scripting with tools like curl or employing highly constrained text-oriented languages traditionally overlooked for web API interaction. Arguments and evidence. Radical transparency and debuggability. SDKs often obscure the exact request and response payloads, error handling logic, and retry mechanisms. By crafting raw HTTP requests, every byte sent and received is explicit and auditable. This is crucial for deep performance tuning, forensic analysis of API interactions, and ensuring compliance in highly regulated environments. Historically, early web service consumers often used raw XML/SOAP requests before the proliferation of complex frameworks, providing unparalleled insight into the protocol's mechanics. Minimalist footprint and reduced attack surface. Every dependency and line of abstract code in an SDK or framework adds to the potential attack surface. A lean custom HTTP client written in a language like C, using raw sockets for extreme cases, or even a well-structured shell script with curl has a significantly smaller memory footprint and fewer external dependencies. This is particularly relevant for resource-constrained environments, e.g. edge devices, embedded systems, or high-security applications where minimizing external code is paramount. Unconstrained customization and optimization. When you're not bound by an SDK's design decisions, you gain unparalleled flexibility to implement highly specialized retry policies, custom caching mechanisms, connection pooling strategies, or unique authentication flows that might not be directly supported or efficiently implementable via an off-the-shelf library. Historical patterns in high-performance computing or network programming where direct manipulation of protocols yields superior results. Historical parallel. Before the ubiquity of ORMs, direct SQL queries were the norm for database interaction. While ORMs offer convenience, many still argue that direct SQL provides better performance, more control, and clearer understanding of database operations, especially for complex queries. Similarly, direct HTTP interaction with Gemini offers a bare metal approach to API consumption. 2. Language agnosticism via domain-specific languages, DSLs, for prompt orchestration. Contrarian viewpoint. General-purpose programming languages are often ill-suited for the semantic and iterative nature of prompt engineering and complex LLM interaction flows. The truly disruptive approach proposes an architecture where a specialized human-readable domain-specific language, DSL, dictates the entire interaction logic with Gemini, from prompt construction and context management to conditional API calls based on Gemini's responses. This DSL would then be interpreted or transpiled into the necessary underlying API calls by a minimal language-agnostic runtime, effectively divorcing the intelligence of the interaction from the execution language. Arguments and evidence. Bridging the gap between prompt engineers and developers. Prompt engineering is an emerging discipline that often requires non-traditional programming skills. A well-designed DSL allows prompt engineers to directly define complex, multi-turn conversations, agentic behaviors, and tool use logic without needing to be proficient in Python or JavaScript. This fosters seamless collaboration and reduces the translation loss between design and implementation. Enhanced maintainability and readability for complex flows. As LLM applications grow, managing intricate prompt chains, function calling logic, and conditional responses within a general-purpose language can become unwieldy. A declarative DSL, tailored to the semantics of LLM interaction, can drastically improve the clarity, modularity, and maintainability of these complex flows. Imagine a prompt-as-code system where the entire interaction journey is defined in a concise, high-level language. Dynamic reconfiguration and hot swapping. Since the interaction logic is defined in a separate DSL, it can potentially be updated, A/B tested, or even dynamically loaded and executed without requiring redeployment of the core application code. This enables rapid iteration on prompt strategies and adaptive AI behaviors in real time, a capability often cumbersome with compiled or tightly coupled general-purpose language solutions. Historical parallel. Regular expressions, regex, are a prime example of a highly successful DSL for text pattern matching, embedded within various programming languages, but fundamentally distinct. SQL is another powerful DSL for database interaction. These DSLs succeed because they abstract away low-level mechanics and provide a highly expressive syntax for a specific problem domain. Similarly, a DSL for LMM orchestration could unlock new levels of expressiveness and efficiency. 3. The data-as-code paradigm. Implicit API invocation via reactive data streams. Contrarian viewpoint. Instead of explicitly calling the Gemini API from within a traditional programming language application, this paradigm suggests that the programming of Gemini interaction should happen implicitly, driven by data events and reactive streams. The core idea is that writing specific data, e.g. a new document to a message queue, a specific field update in a database, or a file landing in a hot folder, automatically triggers a process that formats a prompt, invokes the Gemini API, and then routes the response back into another data stream or store. The programming language here becomes less about imperative control flow and more about data transformation, orchestration, and defining reactive data pipelines. Extreme decoupling and scalability. By operating on a data-in, data-out model, different parts of the system become highly decoupled. Any component can produce data that triggers Gemini, and any other component can consume Gemini's output. This inherently supports massively scalable, event-driven architectures where individual processing units, e.g. serverless functions, stream processors, can be written in any language as long as they adhere to the data contract. Data-first design and observability. This approach forces a data-first mindset, where the data models and their transformations are central. The system's state and flow become highly observable through the data streams themselves, rather than buried within application logs or complex call stacks. This aligns with modern data warehousing and stream processing philosophies, facilitating polyglot persistence and heterogeneous systems. In complex enterprise environments with diverse technology stacks, direct API calls from one language can create tight coupling. By having data act as the trigger and conduit, different teams can contribute components in their preferred languages, as long as they adhere to the shared data schemas. Historical parallel: ETL, extract, transform, load, pipelines, message queue systems like Kafka, RabbitMQ, and reactive programming paradigms, e.g. RxJava, Akka streams, all leverage the idea of data flowing through a series of transformations and reactions. Serverless computing, where functions are triggered by events, e.g. a file upload, a database change, is a modern manifestation of this data-driven implicit invocation. Applying this to LLM interaction treats Gemini not as a direct library call, but as a reactive processing unit in a larger data pipeline. These contrarian viewpoints challenge the conventional wisdom by pushing for deeper control, domain-specific abstraction, or a fundamental shift from explicit code calls to implicit data-driven interactions, offering potentially disruptive pathways for leveraging AI APIs in the future. And that wraps up another edition of Contrarian Coding News, where the status quo is always up for debate.